Dear colleagues and student friends, very good afternoon to you all. So on behalf of the management, faculty and students of Sastra, I am very much delighted to welcome the chief guest of the day, Shri Subramanian Krishnan, Micron's Corporate Vice President of NAND Technology Integration, for this Knowledge Leadership Lecture Series. As the semiconductor ecosystem in our country continues to gain significant momentum, it becomes increasingly important for us as members of the academic community to actively collaborate with industries. Such partnerships are vital to accelerating the growth of the sector, fostering innovation, and driving the creation of IPs that can position our nation at the forefront of the technological advancement. In this context, we are indeed fortunate to have with us Shri Subramanian Krishnan, representing Micron, one of the world's leading semiconductor companies. His presence provides us with the valuable opportunity to gain industry insights, exchange ideas, and explore collaborative avenues that can further strengthen the bridge between academia and the semiconductor industry. And I'm extremely happy to introduce Krishnan sir to this August gathering. Shri Subramanian Krishnan is Micron's Corporate Vice President of NAND Technology Integration and leads a global team developing and deploying best-in-class NAND technology while driving best-in-class performance. Based out of Singapore, Krishnan has more than 3 decades of experience in process engineering and process and device integration in the semiconductor memory industry. He has served in various senior leadership positions across manufacturing and research and development. In 2012, Krishnan took up the challenge of setting up an R&D team in Singapore and has since grown the team to 250 team members who have successfully delivered 5 successive generations of vertical NAND technology to manufacturing. In 2019, he took on the additional responsibility of leading the R&D process integration team in USA too, with the responsibility in early development. In 2024, he was promoted to Corporate Vice President with additional responsibility in pathfinding too. Krishnan is a senior member of the Institute of Electrical and Electronics Engineers. He has published multiple technical papers and holds several patents. Krishnan is a male ally in the Micron Women's Leadership Network and plays an active role on its steering committee. He has been active in mentoring team members and senior technical and people leaders at Micron, many of whom have since advanced to senior and executive leadership roles within both Micron and the broader semiconductor industry. He holds a bachelor degree from the Indian Institute of Technology, Madras, and a master's degree in electrical engineering from the University of Texas at Austin, USA. Krishnan's hobbies include dabbling with golf, listening and performing Indian classic music, systematic reading and sharing of Indic spiritual literature, and corporate leadership counseling. So with this brief introduction, I welcome you all for this Knowledge Leadership Lecture Series. Thank you. So on behalf of the entire Sastra family, I present this memento to Subramanian Krishnan sir.
Guru Brahma, Guru Vishnu, Guru Deva Maheshwara, Guru Sakshat Parabrahma Tasmai Shri Gurave Namaha. It's a rare opportunity for me to be able to speak to this audience at Shastra. Myself and the Vice Chancellor have go many years back. We were in the same school. We share some common thoughts, and he's been wanting me to come here and deliver a lecture for quite some time. So happened that this happened to be a good opportunity. So thank you very much. And just for a show of hands, how many of you are Shastra students? I just want to know how many are faculty, how many are students. Just a quick show of hands. All students? Students. I see still a lot of students there, but not raising your hand. Or maybe not Shastra students, but research scholars. Okay, maybe I should say students and research scholars. Okay. Okay, maybe 50%, rest is probably faculty. Okay. I just want to keep it a little bit entertaining. So after 2 o'clock and lunch, it's typically difficult to keep your eyes awake. Right? So I want to keep it kind of interactive. So today, as an introduction, thank you for the introduction, did want to spend quite some time on understanding this buzzword AI and where the AI and the semiconductor industry intersect. And for India, this is such an important moment that with the ISM, India Semiconductor Mission, and all the effort in academics as well as in the industry to get us to a leadership position for India. So it's very important for the audience and to appreciate what this ecosystem is all about. So all of us who contribute to it have a better understanding of the ecosystem. So that's my attempt to make it relevant to this audience here. So just give me 1 second. So this is the broad outline of the talk. So I'll talk about what is this AI super cycle everyone is talking about. I'll talk about the compute revolution that has happened because of the AI industry, and what does implication of that to the semiconductor industry, which is of relevance to all of us. And as much as the industry is producing all the chips for the AI space, the industry also has to use AI to make the industry more productive. So the industry has to look at it in both levels. How do I make the product for the Google and Amazon and all the other cloud service providers, as well as how do I use AI so that we become more productive? Where can I do more with less? So that's where the AI is used in the industry, and some closing thoughts. So what's this AI super cycle, right? So data explosion, all of you must have heard how the data is exploding we're all used to megabytes to gigabytes. Now we are talking about zettabytes, right? So it's going to 10 to the power 18, 10 to the power 21 kind of rate at which data is generated, and it's tending to double by 2050. Strangely, less than 10% of the data generated is actually being used by us. It's not like we're using 80% of the data. So that's why there is so much data. We were just talking at lunch how data is a new oil, like currency, right? Data is a currency now. Anyone who has access to your data essentially can manipulate anything, right? So, but we're using only 10% of data. That means there is so much scope for this industry by just tapping on existing data, even before we talk about growth of data, right? So you can see the rapid rise of data from the 2000s to where we are, and if we keep plotting, I think it's logarithmic, so it cannot even stay on this paper. It will go outside the paper, right? And this is not just data, but it's fueling economic revolution. So lots of estimates talk about a generation of wealth in this order. Now you can debate, is this the right number or not? That's not important. The productivity that is generated out of this can be a huge wealth generation, and I'll talk about it in the closing thoughts, how much democratization of information that is already happening will continue to happen, leveling the playing field across the whole world, right? There's no such thing as one country has access to something, other country. Internet did that for us. Mobile phones did that for us. This will be another generational seismic shift that will do one more leveling across the world, right? So when you talk about AI today, there are lots of this word AI itself, we can talk for a long time, but I won't go there because I'm sure all of you are reading about it. But you can divide this broadly into 3 or 4 areas. There's what's called perception AI, which is typically what we see. Machines are interpreting the data that we have, whether it's in the factory, sometimes our own devices that we operate, it could be a refrigerator, a washing machine. Those machines interpreting data is perception AI. Generative AI, I think, is a buzzword everyone knows, Gen AI, from the time OpenAI came up with, in terms of the ability for new content generation. It's not analyzing just existing content, but it's able to predict and with all the LLMs, new content generation, which is great, right? Somebody can write an email for me, I'm very happy. It saves me 15 minutes of time. Right? Of course, you need to go check whether the content is right or not, but nevertheless, it's productivity tool, and it generates new content. And then agentic AI, where agents can come together. If you have one agent for a particular function, another agent for another function, these agents can talk to each other. And if you program it in such a way, the agents can make their own decisions based on decision-making tree. So it takes out some bit of human decision-making, where the agents can make decision within a certain boundary. So that's based on environment and context. Then there's a physical AI. I had the opportunity to see a lot of robots this morning in Shastra, right? Lots of robots in self-driving and automation is the physical AI. So there are various aspects, and we are probably exposed to many of these in different forms, but I kind of wanted to say this. AI itself is just a one word, but there are so many different facets of it, right? Now, what's common to all this? What's common to all this is driven out of electronics in the chip industry. None of this can work without a strong semiconductor chip industry, right? None of these devices, none of this automation, none of this data movement can happen without that. And so the semiconductor industry is like a substratum for all these things to work, right? which I'm sure most of you know by now. And so it's driving a huge long-term growth in this industry. So today we are looking at a $600, $700 billion industry. We are looking at a 1 trillion by just 2030. 2030 is not very far. 2030 is just 5 years away. We're looking at a $1 trillion semiconductor industry. And what's more important is the share of memory and storage is going to be as high as like 330 billion, which is over 33%. Today, the share of the memory storage industry, because if you talk about AI, everyone thinks of which company? NVIDIA, right? Everyone thinks of NVIDIA, or maybe some people think of AMD, right? But typically it's talking about the GPU as the heart. But I will show later that GPU is the heart, that's for sure, no change. TSMC, which manufactures for NVIDIA, is the heart of the revolution, but none of that can work without a strong memory storage system around it. So I wanted to kind of dispel that myth that it is all GPU alone that makes the difference, right? So because of that, the share of the memory industry will go from 15 to 30%. That's huge. So the memory industry is going to be as big as $330 billion out of the $1 trillion industry. So that's very, very big. And since I come from Micron and I represent Micron, definitely I will focus on that as a key piece. But so where do we find the usage, right? Where are we finding this AI, which is all around us? Workplace productivity. I mean, I just use email as an example. I use it mostly for summarizing long articles that, somebody will send me an article. Unfortunately, we don't have patience these days to read even beyond one page, right? We all know that. And this is making us even less patient. So tell me 10 points in this message. It's quite good. So if that's all I need, it gives me that pointer, so it's good. Generally for generating emails, or sometimes you are searching within our own company database on something I want to learn. Let's say I want to know what is error correction code. I don't have to go ask 15 people. The ability of Microsoft Copilot to search all the company's documents and give a summary that is 95% accurate, I would say. Fantastic. I've learned about error correction code in probably 10 minutes, 3 minutes maybe. That's the speed at which it gives you the reply with graphs. And so I think it's humongous productivity. Imagine I had to go to ask so many different people what it is. So I think we need to learn how to use it, and prompt engineering, and how comfortable are we getting to using it, that's key, right? Learning is big, right? Because you can customize learning according to the learning capability of the person. That's almost called, if you know the English word called bespoke, B-E-S-P-O-K-E, which means it's customized. So it's customizing learning to the learner. It's not the learning built for the teacher, but it's learning built for the learner, because it will learn along with you and customize the learning. So there's lots of learning opportunities that it doesn't have to be in a traditional classroom, right? Detection and prediction, which I will talk about during the AI in the semiconductor industry. healthcare is big. I think this, all of you would appreciate how quickly can we catch a health problem that's coming up. Maybe it's a cancer, maybe it's something in the blood. How quickly can you catch those things? A radiographer can only read so much of an image. Can it detect things? Today I was witness to many sensors that was built in Shastra that's able to detect how early a rice can go bad, or a fish can go bad, or that's things that matter to the community in this area. So those are fantastic. I mean, that can be automated at scale with AI, where it can detect trends and tell you what to do, right? We have apps and all that. Smart manufacturing, I'll talk about it. And autonomous vehicles, I think everyone knows this. Level 1, level 2, level 3, level 4, level 5 autonomous vehicles. Even if you don't get to full autonomy, where I can take my hands off, the level 3 automation, where it does most of the things for me, is hugely beneficial, right? So there's lots and lots of opportunities. Now, unfortunately, did I say who? Okay, any of you know who this is? Okay, good. So I think everyone knows NVIDIA and Sam Altman, so I'm not surprised. So Sam Altman's made this statement. This is just quote from his X feed on 2:34 a.m. December 27, 22. This is when OpenAI ChatGPT-3 was released, I think, roughly around that time. So he really wanted us to think, and it's not just him, that this is a question asked to him, which is a true thing that you believe in that few people don't agree with or don't understand. He talked about, from a Vedantic standpoint, Atman and Brahman. And the reason he talked about that is because AI is one such concept. He's not saying AI is Brahman, by the way, right? That's why a lot of people are imagining that AI will become super conscious one point. That's not what he said. But basically he's saying it's going to be all around us. It's almost like consciousness, right? And he is very much a Vedantic person, I'm told. I am, so I was very attracted to this quote of his. But essentially it's saying it's going to be all pervasive. I think of that as a message that it's an all pervasive thing, right? So now, next topic, as I said, is based on that introduction, what is the compute revolution that it's leading to? So if you look at the left graph, it's a legacy architecture. I think those of us, I can talk for myself for sure for the last 30 years, those have been used to this industry in the traditional way. We are used to just CPU, DRAM, storage, SSD, and a hard drive. That's all we think. If you look at today's architecture, it's all centered around GPU. CPU is still there, but the graphical processing unit is such a big deal. And the HBM, hybrid high bandwidth memory that surrounds the GPU, that makes that GPU essentially alive, and then how it talks to the CPU and the DRAMs and the low power DRAMs, and completely different architecture, right? Now the world is centered around this architecture, where you can see memory is all around the GPU and the CPU, and the GPU has become a bigger player than even the CPU. So this completely revolutionizes the industry as well as how we look at compute architecture, right? And there are many ways to look at this. One couple of messages here is the fact that memory is important, and the fact that performance becomes an important piece of this, because we are all expecting to type something GPT-3 or 4 and expect a response in 3 seconds. We are not going to wait for 1 minute, right? There was days when I was using what do you call the dial-up internet. Some of you, I'm sure, have seen. You can type something on Yahoo and wait for 1 minute. You may not get a reply. Today we don't have the patience or the time to do that, right? So if you're expecting that, performance becomes extremely important, and at low power, because we are all carrying devices where we want to charge the battery only once. So power is extremely important. So we all have to make low cost, high performance, low power. And this architecture and the AI is not just a data center, which is a traditional view we all had for a long time, that AI will be in the cloud service provider, Amazon, Google will have it, and certainly is there. But now you can clearly see it's AI on our phones, right? There's always a phone version of AI either on the PCs or the phones or the IoTs. So, and which is obviously a low power version, less parameters. You don't have the trillions of parameters that the data center has, maybe millions to billions, but that's what does it on your device, and it is secure. works on your data. What's on the cloud, sometimes we have a level of concern how secure it is, but if it's on your phone, it has got all the security. It is essentially your personal assistant. It is is working ahead of you. It's thinking for you and doing things because it's customized around your needs. What does this person do? Which restaurant does he go to, or what kind of food does he order on any of the apps these days? So it is learning from your experience. So AI is very much the data center and almost and at the edge. So electronics needs to address AI both at the data center level and at the edge devices, right? And this is a very interesting statistics, which is why I said the memory industry is important, that shows, all of you know the GPU is made out of silicon, so is all the high bandwidth memory around the GPU, right? The amount of silicon usage for the HBM die and the base die, you can see 7x that what's used by the GPU. So if GPU is expanding, the memory industry is expanding at 7 times the speed. That's the amount of silicon that's being consumed to support that one GPU. So, and it's a seismic shift in the industry, right? And if you look at the number of parameters that is being used, that's why I say it's kind of going off the chart. This is logarithmic. Still, you can see it's not, can't even capture it. The number of parameters from the GP2 to GP2 to 3 to 4, right? The number of parameters increasing, logarithmically, right? And this is interesting, where you can see, in spite of so much of memory, so much of high performance, there is always still a memory wall where the memory still is not able to keep up with what the GPU wants. The GPU is hungry for data still, because we are, like I said, we are using only 10% of data. If the GPU needs to use more and more of the data, it is still hungry, and the buses are not enough to supply the data, however fast our memory is. So there is still this challenge of performance of the memory at power, at cost, even with so much of memory surrounding the GPU, right? And so much of, and the size of the data is so big that it has to be stored in cache and solid state drives, because what's called data lakes. So that's the storage, and the memory is what does the compute around the GPU. And these data center workloads are also at the edge, right? Industrial level. I know Shastra is working with many industries trying to make automation happen. All IoT devices, they all have AI at the edge, at the industry level, because we can detect sensors, we can detect trends, we can detect early failures, and that automotive is essentially a data center on wheels today. Today's automotive electronics is 20 years back was what is a data center. Just 20 years back, what is data center is today inside the car, right? So in Micron, we call the car as a data center on wheels, right? And then the consumer electronics, right? Your TV is becoming intelligent and so on and so forth, right? And to drive home this message, if you look at the consumption of the memory in AI versus non-AI, you can see clearly a huge shift. When you go into 27, the AI-related applications is going to consume all the memory that the industry is making. That's why the memory storage industry, if you look at the stock price, and the price is doubling and tripling because of this massive usage. Now, I'm switching topic to saying, okay, I do all this for the industry to create great data centers, great edge devices. How do we use it inside the industry? Some of you will be interested, because some of you probably want to join the industry, since it's coming up in India big time. How do you use it in the industry, right? In the next few minutes. So it's founded 1978, so it's about coming close to 50 years, and headquartered in the United States. But we have very large facilities in Taiwan, Japan, Singapore, and the United States. So almost 10,000 people in all these geographies. So it's very big in Singapore. So I sit in Singapore, but I have a global team that's in the United States, as well as in Italy and Japan and in Singapore. We have 60,000 patents and growing, 170 in the Fortune 500 companies, 53,000 people across the world, and in 13 manufacturing sites. And the very successful year. Our year closes between September to August. We had a $37.4 billion year. So it's very, and as I said, all the companies associated with AI are really doing very well now in this current tech boom or the AI super cycle. So products, we make the HBM for the cloud, all the different products, solid state drives, and for the data center, PC market, the mobile market, embedded market, which is all the automotive and the industrial. Now, if you reimagine the memories hierarchy, this may be of interest to a lot of people. We are all used to traditional archived storage, the hard drives. Now we have solid state drives with the capacity usage. We have fast storage, which is the faster and faster SSD drives. Then at the very top is the hot memory, which is close to the processor. So memory industry has to serve this entire storage, entire spectrum, so that it can function very well in combination with the GPUs and the CPUs, right? And as you can see, the arrows show as you go down, the latency gets slower and slower. These are slower storage, but cheap. As you go up, it's faster and faster storage, but expensive, right? As you get close to the processor, right? And like I said in the earlier slide, this memory and storage innovation has to drive performance, because that's what consumers like us demand. It has to drive huge capacities because the data that is being produced is humongous, and also has to be done at low power, because we can't afford to have these things burning power. And everyone wants the next generation of the phone next year at the same price as the previous phone, right? We as a consumer will not pay more this year for the phone just because it's got more features. We want more features at the same price or maybe lower price. So the industry has to constantly drive cost. There's no choice. And in the industry, to meet this demand, to meet this cost, power, etc., we have to produce more bits. As you can see, the graph that shows the process complexity as you scale is getting higher, and the cost still has to go down. So it's a very, and I'm told, as I have talked to some people from aeronautics industry and others, that we think the aeronautical industry has huge amount of innovation, right? We all know how much innovation is there in a plane when you fly. But this industry, from the time it started in the 1960s to now, the rate of innovation, the rate of change that this industry has to do is more than any other industry. So there's no boring moment. Those of you who are planning to join, there's no 1 month in a year that you get bored or something. There's no boring time. There's no time to relax, because the industry is progressing at that kind of a pace, right? And scaling challenges, all of you know, two types of scaling challenges. The memory scaling challenge is all compression on the XY dimension, because we want it to be as small as possible. The storage industry is scaling up in the other direction. Three-dimensional NAND there's no space here, so we need to go higher and higher on the skyscraper concept. So those who come from Tokyo or Singapore or Bombay will know that, how many stories can we go up. So both ways, the technology challenge is equally difficult on both dimensions. XY has its own set of dimension. The Z direction has a problem with all the structural stability, right? Z direction, if you keep stacking more layers, and there's all the, so technological challenge in there in both. And this graph shows that in both industries, the aspect ratio, which is essentially the height, is going up, height versus the dimensions. The nodes are getting complicated. New materials are being introduced. I was talking to the faculty today that material science is the heart of this industry. We all talk about AI and all this, and I will talk about the concluding slide. But without material innovation, no industry can go forward. So it's true of this industry too. So new materials are coming at us all the time, because we need higher and higher performance in the same area, and cost has to be driven down at the same time. So it's a multi-dimensional challenge that's in front of all of us, but that's what keeps engineers excited. That's what keeps the people excited in the science, right? Because there's multi-dimensional challenge. And then we have to really shift left. How quickly can we detect things earlier and earlier with all the data, so that we have smarter development to keep pace with this demand. So as I said, in all, and those who understand industry know the industry has first designs the chip, silicon, then the systems come in, product comes in, then the customers. In every phase, you need to use the data that we have to make things more and more productive, whether it's in design or in silicon level or in system, right? Detecting defects, etc. And as data improves this manufacturing efficiency, this is the last topic I was going to talk about today, and I think those of us from India understand this very well, that sustainability is a core. And actually a lot of the things in industry today are not vectorially pointed towards sustainability, but we have to get it down, because as you can see, there's a talk about the number of the power that's going to be consumed by this data center is going to need nuclear power and multiple power plants, and it's not sustainable, right? So the low power computing and alternative computing is important, so that we don't keep building power plants and burn coal and so on and so forth. So for dharma in our language, essentially sustainability, right? If you support the earth will support us. So we need to understand the dharmic concept is so important for us to appreciate sustainability as we go about this revolution of AI. So the US Department of Energy states that the largest data centers are needing 100 megawatts of power. Can you imagine how many thousands of homes that is going to talk about? And so this is a problem that has to be solved. While we are solving the technology problem, and many countries are doing a lot of work on this. Nuclear power is coming back as a very favorite thing among many countries now, who had said, no, we will never go nuclear. Nuclear power is coming back, or alternate power is coming back, right? So, and then, can we use data for this sustainability also, right? Why not? So much data is being generated. If you are intelligent in how we use the data, we can also make the system more sustainable. So, smart control systems, including people's productivity as well as detecting early faults, don't let things go bad and then repair it. So there are many things. If you have intelligent sensors, you can prevent many catastrophic events which make things more unsustainable. So a lot of sustainability research is also going on in terms of how to make this industry more sustainable in the long run, right? So I think if you look at the trend of thought, AI is key, the industry is important, industry has to use AI to become more productive, but while doing all this, we cannot lose our focus on sustainability. If we lose that, then at the end of the road, the human race has lost out if we lose sustainability. So sustainability is important. So Micron as a company and many other companies have really strong goals on sustainability. It's part of our measurement metrics in the company that we create technology that doesn't meet sustainability indices, we are not done a good job. So we have to, whether it's water or emissions or energy, waste, there are stringent goals that governments impose, as well as we put goals that are even tighter than what the governments need, because we want to be ahead of the statutory government requirements. So all companies need to do that, and we are very much at the heart of that. So I'll leave you a few closing thoughts. So AI is here to stay, right? As Sam Altman said, it's equated to consciousness, but essentially it's going to be is around us, or we are inside AI, whichever way you look at it. Either AI is around us or we are inside AI, but AI is there. And I think there's lots of, and a lot of you are students, I'm sure, are probably wondering, will AI replace my job, right? A lot of social media, if you read, this is a typical topic these days. Is AI going to replace my job, will I have a job, etc. Our CFO has a very interesting statement, and I'm going to say that. It's not proprietary, so I can say it. I really like the statement. He says, an engineer, and I'm just using the word engineer, doesn't have to be engineer, can be physicist or whatever. Engineer cannot be replaced by AI. But an engineer who knows how to use AI can replace an engineer without the person who doesn't know how to use AI. I think that's the crux we have to remember. The AI as a tool will not replace. But an engineer with AI will replace an engineer who doesn't know how to use AI, because some people get far ahead. I think that's a message I want to leave, which means an engineer or a material scientist or a physicist is a material scientist first, then he uses AI. It's not AI engineer. There's nothing called AI engineer, and I'll talk about it in the next slide. This is another myth that a lot of people have, that if I just learn AI, I will be successful. It's not going to happen. You have to have a grounding in physics, chemistry, chemical sciences, material, whatever your you're good at, and the AI is an enhancer to your efforts, right? So don't fear AI. That's not the intent. It is going to be it's going to be your assistant. It's only going to make your life better, and it's going to make you more productive, right? Every country is really focused on semiconductor ecosystem, as is India, many other countries trying to get to self-sufficiency. Government is becoming a big part of this, right? All governments are supporting because there's a sort of national security or national imperative, whichever way you want to call it. And for India, training of skilled personnel is as important. The industry is only as successful as we're able to create the right level of training, trained skilled personnel in locally, as well as be able to attract some talent from outside the country, those who have migrated out or whatever, right? And we need to build an ecosystem in the country, whether it is suppliers, if you want to buy a tool from a supplier X, and if he does not have a base in this country, how is he going to support the tool when it goes down? So we need that. We need the ecosystem for suppliers, for metrology makers or measurement equipment. The entire ecosystem has to be there. And if the industry is big enough, they will have a reason to establish a headquarters in India so they can support all the industry. So this is at scale. We need this. And reliable power, reliable water, logistics, movement of things. As the size of the industry, as you can see, investment is so huge that every minute is dollars. Every minute is hundreds of dollars or millions of dollars. So you cannot have a logistic delay of an equipment coming to a dock and it takes 10 days to come to your facility. It has to be within 24 hours, it has to land in your facility. So you can start making use of it, right? And sustainability cannot be missed at all in this whole thing. And we, to me, I think if one country can conquer sustainability is India. With our values that we have, while we do all this, I think we will not lose our focus on sustainability because that's inbuilt into our way of working, right? We don't even throw a piece of paper, we'll try to write something and keep it. We may not even throw it in the trash. If it's a white piece of paper, we'll still write it. At least I do. I don't know how many people do these days. Maybe people don't write on paper, they write on the phone, so maybe it doesn't matter. But we all write it. My grandfather used to probably tear an envelope if it comes as in the letter and tear it and use the back side of the envelope to write something. So that's is ingrained in our, that we don't throw things away. So I think sustainability is very important. And like I said earlier, how students and faculty should embrace this revolution and not be wary of it. So I said closing thoughts. I have one slide, last slide, and it's called After Closing Thoughts because this is very dear to my mind, so I kind of wanted to share it. And I know in Shastra I can share this with a lot of interest. So I want to quote two verses from the Bhagavad Gita, which I'm sure a lot of people are. I'm not going to ask how many people read Bhagavad Gita. Okay, I don't want to put you on a spot. But the left, I thought it's important for the faculty. Both are important for everyone, but left is important for, let's call it, teachers, or the right is more important for the students. Now, why I say that? The left is this verse from 9 chapter 29. Samoham sarvabhuteshu name dveshtyoshi nat priyaha ye bhajanti tu mam bhaktya maiteshu chapyaham. So he's saying essentially, Lord Krishna says, I bless everyone the same. It's up to you to tap my grace. He's not saying I'm favoring this person, that person. So in some sense, if you look at AI, it's going to be available to all of us, right? Whether you tap or not is up to you. That's why I said an engineer with AI is better than an engineer without AI, because that one person knows how to tap, the other person doesn't know. AI is there, up to you to tap. So I found this verse very appealing to me from that perspective of saying it's up to us to be intelligent to tap this, right? That's what he's saying. So learn to be comfortable. Don't be wary of it. When I talk to faculty in Singapore, sometimes I say, and I read this on the literature also, that my children tell me from school that the days are gone where the teacher is asking, hey, did you write this essay using AI? That day is gone. Right? Now the teacher assumes you probably took AI's help. Ask the student, beyond AI, what did you do? So now the question is changed. Instead of asking, are you using AI, tell me, and that becomes a trick. That's the question for the student, right? He must have added some innovation on top of what AI is, and he has to explain, okay, I took this AI help, but this is what I did on top of it. So it's a coexistence of AI with the student's innovation. I think that's the mode we're all going to go to, right? That's what is happening. The right side is related to what I said on the previous slide comment. So this is verse 35 in chapter 3. Similar verse comes in chapter 18 also. Shreyan swadharmo vigunaha paradharmo svanushitat swadharmam nidanayam shreyaha paradharmo bhayavaha. So what he's saying is swadharma, do your swadharma. So in this language, what does it mean? If you are a chemistry, if you like chemistry, you have to assess for yourself. Do I like material science? Do I like your condensed matter physics, right? So do I like condensed matter physics? Do I like material science? Identify your core area of competence, continue to work. So he says, swadharma, if you do what is your dharma, you cannot not be wrong compared to doing somebody else's dharma, which is, my friend is doing this, let me go do this, has no value, first of all, right? So you have to do your, and why this is important is the one I said earlier, AI, just learning AI is not going to take any of us anywhere. Swadharma is what our core science is. Could be civil engineering, could be mechanical engineering, whatever it is. AI is an enhancer. I tell all the parents I meet that please don't tell your children, go study AI, that's your next job, is going to pay you, lakhs or crores or millions of dollars, whatever it is. It's a wrong advice, right? Learn AI skills. At some point, AI will become like Excel, correct? Do we tell anyone, please go learn Excel to get a job? We don't tell that, right? AI will become Excel. Today is already like Excel. If you go use a Copilot, it's like Excel. It's another tool that gives me something. So don't assume that AI alone. So here clearly it says, do your swadharma. Find your profession more suited to your personality. Pursue it. Have AI as an assistant for you. Don't go for AI. So I thought these two verses, I spend a lot of time on the Gita, helps me a lot. And these days, a lot of AI tools are available that give you a lot of good summaries of Gita also. So we can benefit from AI tools also. But seriously, I thought these two probably made sense to this audience in terms of how you approach this whole entity. At least this is my view. You may have a different two verses that you like, but I thought this made sense to me. With that, I will probably stop, and we should have some time for questions, maybe? Yeah, 10 minutes. Gallium nitride for the battery, the industry, or not even battery, maybe the chargers that we have, high current, the EV chargers, they all coexist, right? The core of memory storage, GPU, CPU is still silicon. At least for the foreseeable couple of decades, I don't think we are going to go out of silicon. Yeah. And first of all, it's cheaply available commodity. That's another thing, right? You just sand in the beach. Ultimately, it is just sand from the beach.
Sure.
Right? It's the cheapest available commodity.
Okay. Thank you, sir. And one more thought. In your last slide from the Gita, the first one is it is around everywhere.
Yes.
But the second one is just contradicting in the sense Sudharma that you are talking. If I have a Sudharma that I don't want to use this kind of AI tool, then what is your suggestion then?
That's a good question. You can choose to, right? I'm sure some people, then you must be just happy with what you do. So Swadharma only says, I pick what I do. You're not competing and comparing against somebody. You can choose, I don't want to use AI. I'm sure you're all reading about Sridhar Vembu and Zoho, right? He's just chosen to ride the cycle. He's not comparing to somebody who's driving a BMW. It's his choice, right? He can buy 10 BMWs. It's a personal choice we make. So no, you can still make a choice, no problem. Yeah. Yes.
In biomedical side, there is a research still going on.
Yes.
How to store data on DNA double stranded, whether it will solve the storage problem, if it works.
Yeah, you're right. The people are always looking at alternatives. Even if you don't go that far into DNA storage and other things, even within the industry, we always look for low power, non-volatile storage and alternative options. The thing is, the industry has built the ecosystem, the interfaces all around typical RAM and storage, that for the industry to replace it, it must be so compelling, because you are rewiring the entire industry from our devices at home to the computers to the data center. So it has got to be extremely compelling. So what we are seeing is not a replacement, but coexistence. When all these things come, they will all find niche. If you remember the slide I had, a hierarchy, so you will have multiple small hierarchical steps in between that will get generated. The big ones will remain, but there will be niche application. Somebody will find the DNA memory is usable. It will find a slot. It will start replacing or it will start coexisting. But replacing the current system, it doesn't look that easy, right? Okay. I should have explained, but I think I went a little bit faster. So very good question. So I can just give you maybe two, there are multiple. So as you know, a large 12-inch wafer comes out, you have, let's say, just pick a number, 1,000 chips coming out. We want to have all the 1,000 yield. That's not going to happen, maybe 90-95%. So how do you find defectivity as they process through the line? Now manually people inspect, but if AI is able to learn, pattern recognize a defect in its early formation and warn, you can make changes so that you can avoid that defect being formed. So essentially that translates to a quality improvement in yield. If this defect still happened, you don't want the die with the chip with the defect to end up in a customer's phone or customer's system. And today we do reliability testing and so many other things, but still things escape. So if we're able to again pattern recognize those things, we can prevent quality events. Second, maintenance of equipments, right? Equipments are they don't fail digitally. They are running well, then analog, there is a general decline in performance. And if you wait for catastrophic failure, you're going to spend a lot of money and downtime, which we can't afford. But if you're able to detect early failures, you are able to intercept or intervene early, prevent a long downtime of the tool, find an alternative way. So these are massive productivity features in the industry. I mean, these are just two. There are many other. But pattern recognition is a key piece, because that's the power of AI, where you can replace an individual looking at defect and classifying. The system can do that. Right? That answer your question? Yes. Yeah. That statement is true. That statement is true. But the percentage of people needed for that is very small. If you look at the AI industry today, if you look at the LLM model developers, if I just use some simple analogy for you, LLM model developers, then users who have made their business more productive, and there are people who customize existing models. The model developer is a minute fraction. The money and the effort is in the people who customize models and the people who use the models to make business more productive. That's the big dollars I talked about is not coming from that portion is there, it's important. But my point has to be taken in perspective. I didn't say that it's not important, but if all it's almost like I would say the IT industry the IT service industry in India, right? It was a boom for so long, and for a long time, whether students or parents are pushing people to go to the IT industry. So many of people I know studied civil engineering, chemical engineering, ended up in IT. I think it's a loss to both. It's a loss to IT industry to have the wrong fit, and we lost the chemical engineer also. So now, does it mean you don't need IT? No, that's not what it is. But why do you want to convert a chemical engineer into IT? So I think it's a matter of finding a proportion. If all parents have to say, go to AI, then I don't think the model industry needs that many people. That's the way I meant. Sorry, I didn't answer the question from there. Sorry. What was the question? What was your question? The lady right behind you. I thought you had a question. Did I answer your question? Okay. Either you can be like him, not use AI at all, then there's no problem. Or you can, that's what you call human in the loop. If you read this article that says there's always a human in the loop. Even if he types an email for you, you better check before he sends. Or he may say something that you didn't want to say at all. Right? Human is still important. Between like a GPU and a memory. I think the closest people are looking at this, I don't know about wireless, but mostly people are still doing optical interconnects, right? Beyond electrical. Optical definitely shows promise, but the optical still has to convert to electrical, right? So I think the problem is not so much the optical doesn't work, is the back conversion and the front conversion is why it's still adopted in small segments but not pervasive everywhere. The electrical, so instead of horizontally conducting things, now we are doing a lot of things vertically, we using silicon pillars and other things, so we can shorten the resistance and pass the signals vertical. So, but you're right, but so far it's still electrical. Less, I have not heard of wireless. Any other questions? Maybe it's yet to be found, I don't know, because we are still in this explosion of models, explosion of parameters, right? I don't think we've reached a point where the model the parameter is plateauing or the chip is not able to take it. I don't have a good answer for you. It's still in the early stages of the increase in parameters probably, but I don't have a very good answer for you. Maybe we'll get to that point at some point. Maybe we are still very, very early in this industry, super early. If you look at it as a large graph, we are probably here. This explosion is still in front of us. So
thank you so much, sir.
Yeah.
Thank you so much.
Yes.
Actually, I'm working on semiconductor devices.
Okay.
So,
Good. We need people like you a lot. Yes.
so we have actually we are doing a lot of stages, right? Like compact modeling of semiconductors,
Yes.
design rule check, DRC check, statistical modeling.
Yes.
So we have some of the industry. When I talked with some of the industry experts, they were saying we want AI generated compact models, AI generated statistical models. So where is the industry with respect to those kind of model generations?
So again, maybe my answer is similar to the earlier piece. A compact modeling engineer still required, a TCAD engineer is still required, but today, let's say we use TCAD or compact modeling to generate a large set of devices and information. We probably run out of steam and we try to probably combine devices and try to simplify the models. But if AI and the large data is available, you can customize the model even better because it gives you more bandwidth. You have only so much time. So if you can generate it on a certain fixed set of parameters and if you can use that to expand, you can design compact models that cover a wide spectrum of devices, which today is probably limited by human capability. We don't have time or the data to go do it. So again, it's only a productivity thing, and maybe the models become more accurate because you model very specific devices, which today we probably don't do. Right? So your job is safe.
In the healthcare simulation area,
Yes.
instead of doctor prescription, AI generated prescription device. How do you believe? How should we understand?
Oh, believe or not believe is a different topic altogether.
Nowadays, AI only is writing all the things. If AI given the printout, go and take the tablet from the
I hope to see a real doctor, not a AI doctor every time I have a problem. If doctors are intelligent, they will not do that. That's the way I look at it. And doctors are intelligent, so. Yeah, thanks. I wanted to say about that. Thanks for reminding Dr. John. So Micron India is, I can simply divide it into two things in your mind. So a big packaging factory is coming up in Gujarat, in Sanand, that you all probably heard of. And we also have a big operation of almost 4,000 people in Hyderabad. I was there last week. And a lot of people think that Hyderabad is only doing IT or services or anything of that sort. It's really not, right? We have solid state drive testing validation. We have DRAM module validation. So it's hardcore engineering work, which needs postgraduates, masters, PhDs, because these are functions that matter to the product quality and to the customer. So these are not jobs that are manufacturing oriented. So whereas the jobs in Gujarat largely will be manufacturing the chip. The chip will come from our factories across the world, but the assembly will be done in Gujarat. So both sets of roles are in Micron. So thanks for reminding. So there's a lot of scope for postgraduates, and I know when I talk to similar groups in Singapore and other countries, there's usually most students want to end up in academics and research institutes thinking there's no scope in the industry. That's not true, right? It's a matter of exposure. I think I'll make sure Micron probably spend some time here, and maybe Shastra spend some time in Hyderabad, but there's a lot of scope, and we have had a lot of masters and PhDs from across the country. So there's plenty of scope for postgraduates who are interested in Micron. So that's the message I want to have. Thank you. Thank you. Thank you for being a very patient audience. So thank you.